10.4, solving quadratic equations in factored form. Factored form. You guys are used to factors. Basically, a factor would be 2 and 6. 2 times 6 is 12. 12 is the product. 2 is a factor, and so is 6. There are factors of 12. But we're going to actually use the binomials, trinomials, and that kind of thing that we've been working on so far in class. And we're going to, I'm going to show you what those factors look like. So to get going, for your vocabulary, factored form. Basically, a polynomial is in factored form if it is written as the product of 2 or more factors. Remember, 2 or more factors, you know, 2 and 2 will multiply to make 4, which is the product. So if I gave you something such as this, x times the quantity, x minus 7, x is a factor and x minus 7, that quantity. That whole quantity, actually, that binomial, is a factor. If I multiplied those together, they would give me a product that looked like that. But we are going to mostly work with the factors in this lesson. Another type, here's a factor here, this quantity, x plus 2 and x plus 5. If I multiplied those together, I would have this for a product. Now, how many factors can I have? Oh my goodness, we can have a bunch. So we got here, here's one with 3, and you can see it came out as a trinomial, or no, excuse me, I forget what it is, but that's all right. This thing comes out with a degree of 3. 3x's right there, kind of maybe give you a hint. The product is the long polynomial here, and here's the factors we're interested in. These factors right here eventually are going to give us, they're going to tell us where the x-intercepts are. Remember the little x-intercepts, so we can know if we're, we can know what kind of graph we're going to make. Could be a quadratic, could be the cubic that looks like a propeller, but we're going to find out. So one key concept with this lesson, the zero product property. That says if a times b equals 0, then either a has to be 0 or b has to be 0. Makes sense. Something's got to be 0 if we're multiplying and we get 0. So let's start off with an example. We're going to solve the equation, the quantity x minus 2 times the quantity x plus 3 equals 0. Equation has an equal sign, so just reminding you of that. The solution is to do this. Let's write the equation. So we take it from wherever we're reading it, we write it out, equals 0. And we're going to set each factor equal to 0 because this allows us, we know that one of these is going to be 0. It has to be 0. And it actually is going to help us find some x-intercepts in the future. Set each factor to 0. So I just took this and went 2 ways with it. I took the x minus 2, set it equal to 0. And then the x plus 3, set it equal to 0, and then just solve for x. Solve for x on this side, you get positive 2. Over here, negative 3. So the solutions are 2 and negative 3. Also, that's going to be the x-intercepts. So I want you to go for it. Where you pause and you're doing the work. Oh, let's see here. X plus 1 equals 0. I know that's going to be x equals a negative 1. On this side will be x minus 3 equals 0. And I know when I solve for x through inverse operations, I get x is 3. Second one up there. Well, this is an interesting deal. This right here, actually, I'm going to set that equal to 0. So the first one, x equals 0, I'm done. So that took care of that one. This one is going to come over here. X minus 2 equals 0. And I know that this will equal positive 2 through inverse operations. And so the solutions are 0 and 0 and 2. This was -1 and 3. And then the last one here real quick. Just split them up. X minus 5 equals 0. That's going to be x equals a positive 5. And x plus 7 equals 0. And that is just going to be x is -7. So really, in this one here, in all of these, the solutions are going to be the x-intercepts. Or the roots. Remember that one. X-intercept. So this is x equals 5 and -7. Example number 2, solve a repeated factor equation. A repeated factor means I'm taking the one factor here, x plus 5, and I'm going to square it. That would be like repeating it. X plus 5, x plus 5. Repeat it. Solve x plus 5 squared equals 0. Again, split it up here, but I don't need to do both sides because one side's going to equal the other one. It's going to be the same thing. So I just x plus 5, I set it equal to 0, x equals -5. -5 is the solution for this particular problem. Remember, that should look like, I put this up here, square of a binomial pattern right there. So if I actually ask you to work that out, I know you can do that. Anyways, have a little quick go for it right there. Okay, we only need to really do just one side of this. X minus 4 equals 0. Therefore, in this solution, this is just going to have a solution of 4, positive 4. And we're done. Okay, so that was for quadratics. We're going to solve a factor cubic equation. Cubic means 3. So that means we've got 3 factors, 2x plus 1, 3x minus 2, x minus 1 equals 0. All you have to do is just set them all to 0 and find out what the solutions are. So we take this one here, 2x plus 1 equals 0. When you work out the math, you will find that x equals a -1/2. Same with this one here. You work it out, you will find that x equals 2/3. And the last one over here, x equals 1. So if I asked you to solve a factor cubic equation, set all of these equal to 0, and just tell me what the solution is. So the solution is -1/2 from here, 2/3, and 1. That means all 3 of those, I can plug any one of those into x. That means I can put -1/2 here, here, and here, and work it out, and it'll be good. Or I can put 2/3 in here, here, and there, and work it out, and it'll be good. And of course, if I put 1 in there, it will also be good for each one of those. All right, here comes the good part. Example 4, graph a factored equation. So whether I give you, this one only has 2 factors to it. That's going to be a quadratic, and so we know we're going to have something like this or like this, depending on if the x squared is a positive or negative. You can take a look, and you can predict right now, are we going to have it facing open or closed? Just by looking at a positive x here and a positive x there, because positive x times positive x is a positive x squared, which means, that's right, opened up. All right, well, what do? Remember, the solutions to a quadratic are the x-intercepts, so that's where they're going to hit the x-axis. And really, we only need the x-intercept, and then we need the vertex. If you remember, the vertex is the at the bottom of the curvature is the point right there. So step one, we're just going to find the x-intercepts. Find the x-intercepts, which means we're just going to solve like we have been in this lesson. Solve for x minus 3 and x plus 2. And of course, if you do that, you will find that this becomes 3 and that becomes negative 2. I have my x-intercepts. That means I'm going to have a negative 2 point on the x-axis and a positive 3 on the x-axis. I know that now. Step 2. Now I'm going to use the x-intercepts. I'm going to use those two guys right there to find the coordinates of the vertex. Something a little new right here for you. The vertex, I need an x and a y. And in order to use these, all I have to do is the x coordinate of the vertex is the average. So the x coordinate will be the average of the x-intercepts. This is awesome. I mean, it looks like a lot of writing right here, but wow, this goes so fast. You can take 3 and negative 2. You're going to find the x-coordinate of the vertex right here. So plug it in. 3 plus a negative 2 divided by 2. How do we find the average of two things? We take the sum and we divide it by 2. Excuse me. So 3 plus a negative 2 divided by 2, that is 1/2. Now I have the x, 1/2 of the vertex. The next thing I'm going to do, I'm going to sub the 1/2 into the original equation here. So let me back out a little bit, or actually, you know what? Let's come on this side. So I took the 1/2, and I'm going to put it in for x here, and I'm going to find out the y. I'm going to find out the y part. So I take 1/2. Let's see, sub 1/2 into the original. So 1/2 for x here, 1/2 for x there. And when I work this out, remember, you're going to have to, you can't add or subtract fractions until you find the common denominator. So I change the fraction up, and what you get is negative 5/2 for this quantity here. And this one ends up being a positive 5/2 for this quantity when you add those two together. Then, this is multiplication right here. So multiplying fractions, we multiply the tops across, bottoms across. Negative 5 times a 5 is a negative 25, and 2 times 2 is 4. So negative 25 over 4 is how we get, I got that from multiplying the two fractions together. So I know now my vertex is, the x-coordinate is 1/2 from here, and the y-coordinate is negative 25/4. Why does the vertex, how is the x-coordinate of the vertex the average of the x-intercepts, especially for a quadratic? Well, remember that a quadratic is like this, and there's a line of symmetry right between the x-axes. So if I can just have this number and this number, I can take the average of these two, and I'll have the center point. Of the vertex. That's why I can use just the average of the two x's. Super cool. Okay, so I've got that. Now all I need is the vertex, and I need the x-intercepts, and I can graph this thing, and we can go from there. So here's what it's going to look like. I rewrote the x-intercepts over here. I've got x is 3, x is negative 2. I've got the vertex at 1/2 and negative 25 over 4. Or I went ahead, and some of you might be more comfortable looking at it as negative 6 and 1/4. I just converted that to a mixed number for you. And so I just graphed these 3 points. So x is 3. Come on over here to 3. Make a dot. X is negative 2. Make a dot right here. Plot a point right there because there's the x-intercepts. And then when I plot the vertex right here, so 1/2, starting 0, this is 1. I forgot to mark that. This is 1 right here. 2, 3, and -1, -2, -3 to help you out. That means halfway is right there, 1/2. So x 1/2, come over 1/2, and drop down 6 1/4. Drop down 6, and it's about right there, because here's be the halfway mark, so it's about right there. Vertex 1/2, -6 1/4, and really normally I know we had 7 points before. We could really do it with 3 and have a pretty good idea of what the parabola is going to look like. And that's what this one ends up being right here. A lot quicker way to find out what the parabola is going to look like just by using factors of the binomial for our quadratic.